All right, today I'd like to talk about inequalities, mainly what they are, how to read them, and how to write them. So an inequality is basically a mathematical sentence that shows the relationship between two quantities that are not equivalent, aka not equal. So let's just look at a couple of examples. We've compared numbers before. We would say that -2 is less than 5. That's an inequality. We could say that 7 is greater than 3. If we were comparing 5 and 7, we could say that 5 is less than or equal to 7. And another one would be 3 is greater than or equal to 3. Well, it's not greater than, but when it says that or equal to part, that makes that a true statement. An algebraic inequality is an inequality that contains one or more variables, such as the example I've given, x is greater than 2. A solution set is just the set of all values that make the statement true. Graphing inequalities, okay? This is the less than sign, okay? Let's use a less than inequality and say that x is less than 5. Well, we'll need a number line, and as far as I'm concerned, just a snapshot, 3 numbers on that number line with our number in the middle. Since it says x is less than 5, I'm going to use an open circle on 5 because 5 is the starting point, but it is not part of my solution. And I'm going to shade the number line to the left or less than. And to check that, I could just take a number in the shaded area and plug it in and say, is 4 less than 5? If it is, I shaded it correctly. Let's look at an example of greater than. Okay, let's say that x is greater than -2. So on our number line, we've just taken a snapshot. We have -3, -2, and -1. And when you're making your number line, if it's negative, make sure you get your numbers going in the right direction. Again, this says x is greater than -2. So -2 is not part of the solution, so I'm going to use an open circle and I'm going to shade it to the right. Now if I plug in -1, since it's in the shaded area, and for x, is -1 greater than -2? Yes, it is. Okay. Our next symbol is less than or equal to. So let's look at how we would graph an inequality using the less than or equal to. Let's say that x is less than or equal to 7. Well, in this case, 7 would make this true because 7 is equal to 7. So this time, instead of using an open circle, I'm going to use a solid dot on 7. That indicates that 7 is part of the solution. And then I'm going to go ahead and shade it to the left or to the less than. And I can take a number from that. I can plug it in. Let's take 6 and plug it in for x. 6 is less than or equal to 7. Our last example here would be the greater than or equal to. So let's see what a graph of that would look like. If we have x is greater than or equal to 3, we're going to take our snapshot of our number line. So we took 2, 3, and 4. In this case, 3 again is part of the solution. So instead of an open circle, we'll do the solid dot again. And we're going to shade it to the right or to the greater side. And if I check that, I can pull a number from the shaded area, such as 4, and plug it in. Is 4 is greater than or equal to 3 a true statement? Yes, it is. So this pretty well covers how you would graph inequalities, whether you're using an open circle or a closed dot, and which way to shade them. Next thing we want to look at is writing inequalities if we're given the graph. Okay, on our top graph, we've got a solid dot on 4 and it's shaded to the right. Well, I know that shaded to the right means greater than, But what does the solid dot mean? It means that 4 is part of my solution. So our correct inequality sign then would be x is greater than or equal to 4. On our second example, we have an open circle on -6, and our shading goes to the left or to the less than side. Is -6 part of our solution? Not, since it has that open circle. So in that case, we're going to say that x is less than -6. All right. On our third example here, we have an open circle on 23, and we have the shading going to the right or to the greater than direction. So let's take a look at that. The open circle on 23 means that 23 is not part of the solution. So we're just going to say that x is greater than 23. On our final example here, let's take a look, and we've got a solid dot on -113, and it's shaded to the left. We know that when we have the solid dot, that means that is part of our solution set. So we're going to use the or equal to. Since this one is shaded to the left, it's going to be x is less than or equal to -113. Well, that wraps it up. So I hope this helps you. Be sure to reach out to us if you need any help. Have a good one.